Okay, and it looks like we are live. Hello. Gonna do maybe a quick stream, maybe not a quick stream. Do have a couple interesting things to show you today. First things first, we're gonna start practical how and why about using quality parts. Now, I'm not gonna name names, but if you recognize this supplier, you'll know exactly who you're dealing with. And that's all I'm gonna do in that regard. There's a reason why you're paying what you're paying for parts, and it's not because they're just as good or great or even equal or even slightly not as good as other aftermarket parts. The reason why you're paying what you're paying is because you get stuff like this. That doesn't look healthy. Oh, that actually looks like shit. Oh, it's not supposed to look like that. What is that? What is this? When you go and peel one of these off, and that's literally what happens, so you go to remove it from the phone and you end up peeling the connector away from the FPC, and this is what you end up with. This was sent in from a good friend of mine. And we'd had the conversation about these particular parts before, and said, well, it's been so far so good. And a few weeks later, he calls me and says, hey, I see what you mean. so this is where we're at. What I'm gonna try and do is just get this junk out of here so a new one goes in without any kind of residual effect. Hopefully we don't have to replace this entire connector on the board, because that would be pretty unfortunate. But here we go. Yeah, it's coming. Ooh, there's a big chunk of metal there. As long as these teeth are coming out of the broken off connector and they're not coming off of the actual phone side, we're going to be okay. But I am going to really gingerly try and pick all of this extra material out of here. We don't actually want to do what I just did right there. That stays. That's not part of the messed up connector. You go back from whence you came. Okay, stay. This has to come out though. And I know my microscope is considerably more wobbly. I switched to this articulating arm rather than the 50-pound base with the weird double boom coming off of it, just because you get way more range, and my particular setup here kind of needs a little bit more range. One problem I was having with the other one is it's really difficult to, and it looks like we got that out of there. I'm going to go ahead and grab a working screen and plug it in, just so I can make sure when my friend gets this back, he can plug in a screen. From not that supplier, you hear me? Stop using those guys. Stop. And get his customer back up and running. So, all right, let's go grab a 6S Plus. You can't see me, but you can hear me. 6S Plus. Okay, and I mean, for the sake of full disclosure as well, I am using an aftermarket screen. I use them in many of my repairs, especially on older phones like the 6S and 6S Plus, my specific policy is for the first year the phone is out. So basically, while it's there goes the train. It always chooses the really the best times to come by and grace us with its beautiful song. But anyway, for the first year the phone's out, while it's still under warranty from Apple, I want to use OEM equivalent, so generally speaking, refurbished original screens. So that way, when they inevitably put out these anti-customer patches like, let's do this, like they just did with 11.3 on the iPhone 8, which disabled aftermarket screens for no good reason until we could get the firmware updated again. I don't have to worry about my customers who are rightfully so going to be upset about the screen repair not working on their $800 phone. And that's kind of what justifies it in my mind. If your phone's $800, don't tell me that $200 or $250 is too much for a new screen. You can't go replace that phone. But then after that, once they're out of warranty, older phones, and the aftermarket has had time to catch up and actually produce some quality screens, I got no problem with using aftermarket, especially when our good reputable suppliers are going to give us the same kind of warranty that we give our customers, which is lifetime, basically, and make sure these things are going to work perfectly. So the screen I'm installing is from Mobile Centrics. Big fan of those guys. Good team over there, good support. Ooh, come on. Give me some love. Okay, we got a battery symbol showing on the screen, so we'll let this one charge for a few minutes and we'll do the next one. Yeah, this is not one but two screens did this. Alright, this one looks like it'll be a little bit easier. Let's switch to the other camera here. This one's got a nice, the whole wad just flopped off of there. It was the way that scope is shaky. I see upgrades in my future. Come on. You can do it. You can do it, little guy. Get on out of there. Let me not use my new best good tweezers. Let's use some a little bit older ones. These Hacko CHP tweezers are great, by the way. That's not my new best good ones, but these are $3 or $4 tweezers, and you can do a ton of work with them before they eventually get bent up and unusable. And they have decently precise tips. They're not in the same ballpark as the Dumont tweezers. You can see these are that's a whole different class of tool right there. Two completely different classes of tool. Well, I was hoping this one was going to be easier, but it's not. difficult is not a word I would use still to describe this procedure. Maybe annoying. Come on, you can do it. You can do it. You can do it. Alright, make sure we don't leave any of these little chunks in here now. Very important. And don't let it flop over to the next connector. Okay, let's see. These look serviceable now, so I guess I could have grabbed the iPhone 7 screen. 7 Plus. iPhone 7 Plus. Alright, let's plug this bad boy in. You don't need a microscope to plug in screens, but if you have a microscope, it makes really every part of the job just so much more fun all around. Okay, and because this is an iPhone 7 with no home button or proximity sensor plugged in, if it starts up all the way, if it's going to take a long time to do so. Okay, so we have. Okay, so we have an Apple logo, so we'll leave this one here. Can you see that? No, we'll put it there. Okay, so we can kind of keep an eye on that one, and I guess we'll keep an eye on this one too. There, you can kind of see both of them, sort of. Okay, now on to actual board repairs. Now that the housekeeping is finished. Housekeeping. You want me fix your phone? Okay. This is an iPhone 6S Plus. 6S Plus. We're getting no power. It's not charging. When we plug it into the USB amp meter, we're going to pull 0 amps. That can be caused by a lot of things. It would help to take all the screws out of this. I suppose since this is live, I should just go ahead and disassemble this whole phone. Right here. Boy, I got a bunch of stuff in progress tonight. Oh boy. Okay. You're probably gonna need to borrow your cable. Our 7 Plus is still booting. This is what happens when you don't have a home button. They're just touchy. All right. First things first. Let's get this 6S Plus open. Just to be clear, my screen that I'm installing is Mobile Centrics. I'm vouching for them. They are not the bad guys. They're the good guys. I'm not naming the manufacturer or seller of the screens that are falling apart in these phones. But anybody who's been in this industry for any length of time should recognize that part and know exactly who I'm talking about. And that's really all I need to say about that. Battery first, then screen, as is the custom. He's texting me. Who's that texting me? And I'm not used to having all the screws out next to on my silicone pad here, but I suppose I could have done some of this off camera. That's okay. Alright, let's see what's going on with this battery. So step one, we have no power. Okay. Okay. Hello. I'm gonna go ahead and turn this down. You funny. You so funny. So when you have no power, let's figure out why. What gives the phone power? Well, battery is a good place to start. Let's see what's going on with the battery. This battery is reporting 0.0 volts. Battery is completely dead. So these batteries are rated at 3.8 volts. That's basically your minimum, what this thing needs to even turn the phone on. It's around 3.8, 3.7, 3.8. When it drops below that, the battery's own logic circuit is going to see it as not enough voltage to provide sufficient power to this phone. It's going to shut it off. So a dead battery, if the phone's dead but you're still getting, your charging icon, it can have anywhere from 3.7 to 3.0, or they'll usually have some voltage on them, even if it's been sitting for 2 months. It's usually gonna have something. So if you have a flat line 0, 0, what that usually means is you have a short to ground somewhere. So bear with me for a minute. We need to get this board all the way out. Okay, so what did we say was going on here? This is probably a main power rail short to ground. Are we in agreement on that? I think we are. Okay. Oh, good. This phone has it's been repaired before, but it's using a quality part from a reputable supply. Pleased to see that, happy to see that. First thing we're going to look for is any evidence of liquid damage. This phone does not have any evidence of liquid damage. So next thing we're going to look for, let's go ahead and get these. What are you doing? Let's get these off of here. Oh. Okay, we're going to go to 6S plus. My mouse is kind of going bananas right now. Okay. Are you done? Are you done going nuts? No, not even close. This is going to be interesting. Okay, well, let's do this. Oh my god. Maybe let's try this. Maybe this one will work better. I have two Bluetooth mice. Alright. First things first. We're gonna look on this side of the board. And these are both VCC main. That's a good spot to check before we pull anything off. So let's put the multimeter in diode mode. We got a beep. We'll do a red probe on ground, as is the custom. Black on main. Alright, so we got 2.6 is what we're getting back off of this. 2.6. Or 0.26, sorry. Now we got 336. Uh-oh. Uh-oh. It's officially a weird one. It's official. It's not a dead short on main power rail. Now what? Well, let's keep poking at it, see what happens. First things first, we'll go ahead and get these off. Let's put a little heat on these stickers to loosen up the adhesive. I like to pull them off in a fashion where they'll just easily stick back down. Sometimes that's a pipe dream, but usually they come up pretty okay. .6S plus battery is totes dead, bruh. And we don't have a main power rail short to ground. Alright, maybe the next thing to do is go ahead and see what it does with a not dead battery. See if it powers back up. I'm gonna need more cables. Alright, I don't need to see what you're pulling. Oh no, it requires that it's updated. Yeah, I know. Update, 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 update. I'm multitasking 4 repairs at once right now. Oh, I bet our 7 Plus is trying to come on. So we can't test much on here. We missed the opportunity to put the passcode in. So unless it has assistive touch on, yeah, we don't. So no surprise that it can't activate Touch ID. We can test the touchscreen, a bit, just to make sure we didn't lose functionality on it. And it seems to respond the whole way. There's no reason to think. I didn't see any damage inside that connector, so there's no reason to think that this thing won't work fine. However, when we're not provided a screen to begin with, and I can't test it beforehand, it's really hard to take responsibility for any functionality afterwards when we couldn't see it working in the first place. However, I think we're good to go on our 7 Plus. with the crappy part. Junkparts.com. That's what they should name their business. Don't buy this crap.com. They'd make a killing still. People would buy it just to spite themselves. Did you see don't buy this crap.com? Isn't it funny? Let's buy some of that crap. Alright, we're still waiting for this one. And we're still waiting for this one to do something with its life. We don't need no stinking cables. Alright. How about another lightning cable? I only got 15 cables hanging off my power block here. Alright. So we have a not dead battery here, 6S. 6S and 6S Plus use the same battery connector. So if you're just doing that thing, just grab one, plug it in. Don't get a crappy one. Don't get an old battery with 900 charge cycles on it. Alright. So with a not dead battery, maybe we should verify that. Pretty sure my battery's not dead. And this is a known working charging port as well. Battery. Yep, 4.09. So that's a mostly charged battery right there. We're still in a known good test charging port. We're still getting 0 through USB. No prompt to boot, no signs of life, no power. So what we'll do next is go directly through the battery connector and see if it's pulling that voltage and sending it somewhere else. See if we've got any signs of life here. Okay, 4.2 volts. Oh, we do have Power Z. See if this is going to work today. Of course not. Why would it even? Power Z can't even. Sometimes Power Z is just a basic white girl at Starbucks. Let's give it one more chance. Hey, okay. You temperamental hooker. Alright. What is this? I think it's frozen. Alright, we're gonna try one more time, then I'm gonna have to actually try and fix this thing instead of setting up this stupid setup. Yeah, okay, well, I'll narrate. Alright, so we have the battery connector activated. We have a live battery according to what this phone can see. We're pulling 0. When I prompt it to boot, we're going to pull 0.26. And it's kind of cycling right now between 0 and 0.26. Yeah. We'll do this one more time. One more time, just because it's fun to watch. Yeah, no. Well, Well, we just got a beep out of this one. Let's go ahead and test it. iPhone's disabled. Okay, well, digitizer works. Okay. Let's see if the home button works. I'd love to know. Okay. Yeah. For our purposes, we're gonna call that good, because all we did was dig out some leftover screen connector material for the low price of free. This is a good customer. I don't mind taking care of him. Okay. You go here. And that's yours. You go here. Alright. We're still stuck in this 0.25 boot cycle. And it's not even it's not a boot cycle that gives us a whole lot of signs of life, a lot of hope here. It's more like a death cycle, a death spiral. If you have a loop, if you have an Apple logo or something, it's kind of gives you something to go on. But right now, we're just getting a whole bunch of nothing. And it's not pulling anything through USB. It's a complete flat line with a completely dead battery. You know what? I said I didn't think it was Tristar, but Tristar is easy enough to change. Maybe we'll just start out with some dumb no-brain stuff real quick and see if we get a result from Tristar and Tigris, and then if we get no response whatsoever from that, maybe we can look a little bit further. "6S not charging." Technically that's true. It's also not powering on or showing any signs of life whatsoever. Let's see if it goes into DFU mode. That's a good experiment. So what do we need for DFU mode? We need a screen. We need a charging port. We need a power button and a home button. I think we'll just throw it back in the housing real quick for that. Does it talk to us in DFU? I'm just trying to get any information we can before we start throwing parts at this thing. If it shows up in DFU mode, and if it's cycling right now because it doesn't have any instructions, and it doesn't know what to do because its firmware has been corrupted, or who knows. Let's double check our paperwork here. Is this a data job also? Do not restore. Okay. I'll not restore. But I will see if it can talk to the computer in DFU mode at the very least. Okay. Alright, so we have a... I've already got another one plugged in right now, but it's going to be error. I know. Oh, error 26. Okay, well, let's write that down and we'll set it to the side. Error 26. That sounds kind of nandy to me. I'll have to double check my error codes on the 6S. But, alright. Okay. And no thanks, Apple. Don't care about whatever you're saying to me right now. We'll try and put it in the DFU mode and see if we get any kind of response, any kind of communication to the computer here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not looking good. Okay, we're gonna say negative response on DFU. Okay. So that could be inability of the processor to talk to the USB. Could be instructions getting interrupted. Could be I'm kind of wishful thinking towards Tristar. Let's probe around the board a little bit, look for any kind of clues. This one might be a tough one. We have no evidence of water damage. No evidence of abuse outside of a cracked screen, but it doesn't look it's not something real nasty. If anything, we might have a slight banana shape to the housing there. Just ever so slightly. Might be bent. I don't think that's enough to give us a complete brain dead situation. Let's probe around and just kind of check some of the usual suspects and see if anything anomalous pops out. So we're going to go in diode mode. Red probe on ground. We had a weird reading from main earlier. 284. That's a weird reading. That is not what it's supposed to be. And when I checked it again, it went up to 336. We're at 284, 285. I wonder. 6S's are really bad about getting a short to ground within the Wi-Fi chip, and it'll manifest at the LDO that's buried in there. I've tried chasing it further, but it always seemed like the short itself was within the actual Wi-Fi chip. Let's check some of our stuff around Tristar. $635. So double check what that circuit is. These are our two data lines for USB data. These two little. You can't see anything up there. I need to be a little more conscious of that. Alright, let's look down here. This is Tigris's zone. Nothing real low. We're getting 5 and 600s. We're 1600 on USB 5 volt. Well, this looks pretty normal. This reading 330. What the fuck? Sometimes it's 260, sometimes it's 330. 330 is good, 260 is bad. Now, as we start going around these CPU and GPU power rails, you're going to get what sounds like a short. It's not. These are low voltage, high current lines. They have just naturally low resistance to ground because they're going straight into the SoC for power. It's usually actually better to measure these in ohm mode if you suspect something. Now, if you get triple zeros, then yeah, you got a problem. But we're at 017 on, what is that one? GPU. Yeah, that is not our problem. All right. Why are we getting such a weird reading? Oh, you know what we can check? Let's look at our NAND power supplies. 1V8, OV9, 3VO. That's easy enough. This is 1V8. If PP1V8 is missing, the whole phone will not turn on, so that would be another thing to check. But we don't have any shorts on these. Okay. Really concerned about this wacky reading I keep getting on main. Now it's 330. It's back to normal. Back to behaving itself. Let's go back into our boot cycle here, and let's monitor some voltages. Let's see what is turning on and what's not turning on. Probably not necessary to plug the screen in for this, but I like to do it anyway because in this case it's probably not going to matter. This thing's really not trying to turn on. Alright, 0, 260, cycling down to 0, back up to 260. See if Power Z's playing nice yet. No, it's not. I really like this tool, but it's really temperamental about when it wants to actually work. Alright, let's measure some voltages. So we've got cycling going on. Alright, it's a cyclist. Let's see what our shitty VCC main is doing. 3.9 up to 4.2. Something's pulling it down. Something's pulling you down. This thing ought to be battery voltage pretty much all the time. Sometimes this kind of fuckery will manifest itself as heat. Let's keep probing before we do anything weird. Still in the information gathering stage here. GPU, no surprise, is 0. No fucks, don't care about that. Let's see what 1V8's doing. 1.793. That's within tolerance. And it's dropping out. 1, 2, 3. Ooh. One, 2, 3, 4, 5, 6, So it's like a 5-second boot cycle. Alright, so our 0v9 is 0.899. That's certainly within tolerance. What's our 3VO doing? 2.986. That's fine. It's kind of strange that everything is just a shade under where it ought to be. I'm still incredulous about VCC main. That I'm betting. Yeah. So when our amp meter drops to 0, main goes up to DC power supply voltage, which is 4.2, and then it drops to 3.9 as it's starting up. That might be normalish behavior. But 0.14, 0.13. That's not a normal voltage. Who are you? What's your name? 5VO USB. We don't have 5VO USB running right now. Let's see if we can one-hand this. How are we gonna do this? Ooh, that's a nice little ground spot. Alright, when I tell it to have USB, it's 5 even. When we tell it not to have USB, it kind of bleeds down, which is normal. Let's see. Main, not very interesting. Tigris PMID. Let's see what you're doing up there. 3.9, 3.8. That doesn't seem like normal behavior. Of course, we're in a cycle, so everything kind of boosting and then bleeding down. So 3, 4. That is Tristar pin. Tristar pin is not a normal voltage at all. If this is Tristar the whole time, I'm just wasting shitloads of everybody's time. We do not have normal voltages there. Tristar pin is usually 3 volts. Tristar bypass is usually 3 volts. V8, 0v9. Let's see, are you 0.9? No, you're nothing. You're just nothing. That might not mean anything. That could just be for baseband. It's not even getting to the baseband boot sequence. Okay. Well, since it's my show, I'm gonna replace Tristar. Tristar pin and Tristar bypass are not getting anything close to normal voltages. So maybe we got a burnt up Tristar. Tristar touches so many things when it burns up, it in theory could pull VCC main down as it shits itself. I got plenty of 1610A3s. To say that, I got one little strip of them left. Guess it's time to order that. Where'd you go? Alright, Tristar. Be gone thou. Be thee gone. Ye shalt be it no more. Come on. Get all melty. Yeah, we have to clean those pads up. I fat fingered it and tapped the chip while it was melty. Oh man. That's okay. Get on off of there now. Don't pull those. You happy? Okay. Okay. Alright, we got some nice even pads on the board. I'm just willy-nilly Tristar and shit tonight. Last time, if you watched last stream, that was kind of obvious. That was a Tristar problem. This one's not so obvious. But hey, stranger things have happened. Let's be optimistic. That's what they call me. Mr. Optimistic. My wife's still watching, she'll vouch for that, right? And that's in place. Okay, we have a Tristar. You want to do Tigris? A lot of times if Tristar is dead but Tigris is not, you'll actually pull something like 0.48. Tigris can kind of do that on its own. It can do bad all by itself. Let's do it. Let's just do it. If it boots up after this, how are we going to know which one was which? Which one did it? Was it Tristar or was it Tigris? Let's do it. Let's test in between. I want to know. If it doesn't do anything right now, I'll probably throw a Tigris on it. And then after that, I'm going to scratch my head for a few minutes. Screen, battery, dock. Give me a plug. Give me some power. Oh, we had 0.18 for a split second. Hot diggity dog. Look at this. This phone's starting to turn on right now. Okay. What a learning experience. Phone's turning on, but we're not out the woods yet. We've still got triple zeros on our amp meter. So it's getting a prompt to boot, but it is not running off of USB power right now, which it should be. Did he give me a passcode? We're getting a battery percentage reading. That's good. We're not getting a charging indicator. Okay. 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 Just Just out of curiosity, let's see if we get a data connection to the computer. I'm saying probably not. If you don't have a charging indicator, you probably don't have a data connection either. Okay, okay. So the last one we had like this, I want to say, was also a short on PP3VO Tristar. Which, where are you? Not there. 88, 3VO Tristar. Let's look at that. Let's see. I'm gonna put Tigris on here for sure now, just since we've got a phone that's on. It's ooh. We had a phone that's on, so I unplugged the battery. All right. Well, let's do Tigris next. I don't think Tigris is going to correct our not talking to the computer situation here. I'm reasonably certain we probed this one and didn't get a anomalous reading, but it's good to be sure. 370 on 3VO Tristar. All right. Let's go ahead and do Tigris. I want to pull good amperage and know that I'm plugged in. That's progress. I did not expect this to be a Tristar job. Not when you pull the battery off and it's totes dead. However, that I got a better feeling about Tigris now, because Tigris does connect to the battery directly, and if it's shot, Tigris never needs a lot of heat. Tigris is a very agreeable chip. It wants to come off. You wanna pull me off? Never mind. I just heard myself say that. That was. Uh-oh. Let's not bridge those together. They're the same circuit. That's not going to hurt anything, but that's just ugly work. That's just not pretty. And we all know pretty work is good work. So let's make these pads beautiful. Some fresh leaded solder. Okay. Let's get some of this extra off of those. Damn. Okay. Okay. Okay, I see you. I know what to do with you. I already know what you need. You just need a gentle touch. Yeah, one of my pads has a little too much solder on it for Tigris. So. Oh, you. Okay. Okay. This is what you wanted. We just turn these two caps into one big cap. Effectively, that's all they are on the board, but damn it, I don't want it to look like that. I want it to look pretty. My board does hold some heat, though. This is still melted. You don't want to add any pubes to this situation. Oh, that's not the right thing. That's the right knob. Why does this thing want to look like crap all of a sudden? You wanted to look beautiful a second ago. Now you want to look like crap. Nuh-uh. Okay. Everybody satisfied? Everybody good? Okay. Let's get our new Tigris. SN24 Uebo. Abo. Uabo. Walk on over there. Walk on over. Okay. Okay. Son of a bitch. Look at this. This is nonsense. Maybe I'll turn the air down a little bit, but this is just uncalled for. Come on. Come on. Go where you belong. Man, we've just got cross pollination everywhere right here right now. Right, meow. Wow. Okay. How to prove to the world that you suck at soldering. Look at this nonsense. Jeez. What a freaking mess. Okay. You go back. There you go. Now I'll let everything harden up for a second here because this is just getting out of control. This little rowdy capacitor just causing all kind of trouble. You stay. Okay, you good, brah? You good? Cool this thing off. Oh, of course, it's entirely out of focus. That's alright. You didn't miss anything. You did not want to see that freaking travesty. Make sure none of this came loose. This side of the board got plenty hot. We're right towards the edge where there's not a ton of thermal mass, even in the ground plane. So it's pretty easy to knock a lot of this stuff loose if you're careless. All right, let's give it another go. Anything is possible if you only believe. Okay, screen, battery, dock, power, prompt to boot, no amperage. Prompting to boot, not pulling anything. So now we have a decision to make. I've already made mine. But that is, do we trust that the brand new Tristar we just installed is 100% good? And the answer for me is nah, bruh. No, I don't 100% trust it. Now, if we put another one on and we get the exact same results, okay, I'll accept that. we'll put on the old thinking hat. But it's late. I was wanting to stream all day, but it was just kind of a busy day at the shop. It was never a reasonable opportunity to do so. So now here I am. Let's see what we have on 3VO Tristar. We have 2.994 volts. Okay. That's okay. Let's see what we have on VCC main. What are you doing, you weird VCC main? Sometimes you're 330, sometimes you're 280. 3.95, 3.96. Yeah, that's pretty consistent. Okay. We don't have a data connection to the computer, so we can look at. Show you what I'm looking at. So here's Tristar, right here. These two coils, L5420. You can see just by the name, it tells you exactly what they are. USB AP data N, USB AP data P. So it's a 2-channel positive P, negative N data line going from Tristar to AP, which in this instance is, and it's up here somewhere. There you go. That little dot there, that little dot there. This is the data connection from Tristar, USB data from Tristar here and here to the processor. If these are blown, if they don't have continuity across them, well, then we would not have data. That would be an explanation. You'll remember this one wanted a little bit of extra attention. .38, .38. I'm measuring voltage right now on each side of this. 0.37 on either side. Getting identical readings there. I don't believe that those are open. Alright, so what's next? I want to put another Tristar on here. I'm not about to get trolled by a bad component. Not in the mood for that. I've never been in the mood for that, but I can't imagine myself being in the mood for getting trolled by a bad component. Maybe in the case where it would actually be a relief. If I had spent 2 days trying to get data off of a water damaged phone and found out that I installed, a bad Mason chip or something and was getting no touch just because of my chip, that would be a relief. But right now, no. Alright. So we did Tigris for fun. Tristar actually had an effect. Tigris did not. No effect from Tigris. Which shouldn't really be a surprise. I think it's worth doing anyway, just when you're flying blind. Okay. Let's do Tristar one more time. Comma. Alright. That one pulled out nice and clean. I'm gonna set this over here. Starting starting to run low on these. If we get identical results from this one, I'll put the one we just pulled back in the reel and we'll try it on another one later. The other possibility is we have a short somewhere. You remember when I first plugged it in, we got 0.18 and it prompted to boot, and then we got nothing after that. That 0.18 might have been a death rattle of another Tristar blowing, because there's something short going into it. Let's start checking stuff before we do that. Alright. USB baseband data. Baseband data talks to Tristar? It sure does. Okay. Baseband data talks to USB. Oh, okay. You say so. USB brick ID. Not connected. Oh. You want to look with me? Okay. I'm just poking down all these lines right now. Arc single wire. Arc V-boost. Yeah, let's well, I wonder what Arc V-boost is doing. Oh, that's a bunch of no stuff. Shit. What? Do we even have the same layout? No. Oh. Never mind. Pay no attention. Pay no attention to me. AP debug, accessory. Alright, so these are all data lines going from Tristar to processor. SD RAM, let's see how you're doing. How you doing, baby? We already know SD RAM had 1.795 and 1.793. $255 in diode mode. Alright, that was a little fella next to it. I think that was a 3VO Tristar, yeah. We had 2.99 volts on 3VO Tristar. That was our culprit last time. Not going to be the culprit this time. Tristar pin. This one had a super low reading. Alright, now we also have a reverse gate 5VO USB transistor. Don't know if this is a P channel or N channel transistor. Don't know. I do not know. Let's see if replacing Tristar again is going to give us any love. You know what I'm going to do, actually? Try another charging port. Just to say I did. Six S plus. Anybody who's looking to hold me to scientific method on this is probably cringing right now. I'm changing multiple variables in between measurements. Sorry. I kind of want it fixed. Okay. 0.3. Oh boy. Oh boy. You seeing what I'm seeing? Yeah, you are. 1.5 amps. 1.5, 1.4. So I have a theory. I'm not gonna share my theory. My theory, here's my story, and I'm sticking to it. We had a bad Tristar, and I just did the dock, just cuts. Pay no attention to that. My theory probably lines up with your theory that maybe I'm not as smart as I want people to believe. But hey, we fixed it with 2 Tristars and a Tigris. So now the next thing to do is throw this back in the phone's housing, make sure everything in there actually does work. Son of a gun. Get yourself back in there. Now. Right now. Okay. Okay. I'm gonna edit that out. I'm not even gonna acknowledge what I did. Nope. Not even gonna. If you watch closely, you'll see what happened. It was Tristar. It was Tristar. Sticking with that. Let's do this. I don't think we put enough flux to justify a whole ultrasonic cleaning. Let's get our residue out. Give it a little scrub a dub here. Scrub a dub, I was in the tub. Give it a little hose down. Ooh. There's still a bit of flux in there. I don't give a flux. Yeah, some of this spent a little bit of time down here, kind of crystallized, and we'll shoot it out of there, and we'll liquefy it again with some heat, and then blast it out again. Yeah, that's not pretty. Wow, looks like looks like a scene from Alien or something. Mama. There we go. That's starting to look a little cleaner. I do want my repair to last. I do not want it coming back. I definitely don't want to cause additional problems a year from now due to corrosion from a flux eating away at these components. So it's worth spending the extra time to get it out of there. Nope, not you. Where'd my stickers go? Give me my stickers back. There's one. There's the other. Nope, that's not it. That goes to a 7. Oh, here it is. Who'd have thunk that blowing air all over my workstation would displace the stickers that I left sitting on it. I don't even think Nostradamus could have predicted that one. No. So I guess the takeaway from here is when in doubt, Tristar. And if that doesn't work, Tristar again. Son of a bitch. That's probably a good time to order more of those Tristar chips. I had, if there were 10 of them in that little strip, I think probably 2 or 3 of them were actually bad. There's no way around it. That's slightly annoying. That's counterproductive. I don't want to pat myself on the back too much because I did something kind of ignorant, but having to put 2 Tristars on is that's annoying. Especially when you're doing it as a damn experiment anyway. Not sure. There's no other explanation. There's no other clue. I guess the fact that there was no other clue was the only real clue. If there's no signs of trauma or damage, what else could have been done to this phone that would give it a no power symptom? Well, the answer to that is what causes Tristar to go out. Oh, yeah, get that quantum glow. What causes Tristar to go out? When you use a non-MFI certified cable. You use a crappy charge cable to charge your phone. When you combine that with something like, plugging it into a car charger, which I'm not knocking, but you got to realize your car charger is way more subject to fluctuations than your house charger is. House charger is connected to what's pretty much regulated, a clean 60 hertz AC power supply coming from your power company. So unless you get a lightning strike very nearby that your grid can't absorb, or you get, you know, some sort of other surge, you're really sending pretty consistent energy into the charger when you got it plugged into your wall at home. But you plug it into the car, you turn off an alternator, it's constantly going up and down as the engine RPMs change. I'm spoiling myself using a microscope to plug this shit in, but honestly, I got nothing to prove in that regard. I think my eyesight's starting to catch up with me. I ain't no spring chicken anymore. I'm not quite knocking on death's door yet either. I'm 33. That's a ripe age. I got a few years under my belt. I got plenty more ahead of me. Okay, what are we getting? All right, I'm gonna prompt boot. We're up to 0.4. I would really love to see more than that on a dead battery. Come on, dude. You need to do. Wait, there we go. There we go. Need a little pep talk. 1.3. See? Talk to your electronics. Let them know what you expect. Don't let them make up their own mind and do their own thing. You gonna give me 0.46 charging a dead battery? Nah, baby. That's not acceptable. That's not what anybody wants. It's not good for any of us. Well, it's all over but the crying now. So I'm gonna go ahead and put these back together. They'll be ready to box up and ship out tomorrow. I guess that's gonna do it. Remember, when in doubt, you might as well do a TriStar. If that doesn't work, sometimes you might have to do another TriStar. But thanks for watching, and we'll see you in the next one. Adios.